Here I am looking at homework 12B with you. I'm going to change problem 1 slightly, but you'll be able to follow what I've done and use it to solve your own problem. So your worksheet said it's 1/4 of their weight. I'm going to pretend I have a different situation, and the force of the air resistance is 1/2 of their weight. So I'll just hide that 1/4 part right there, but I still have the picture. It's not good enough, though. I need a free body diagram. But you know what? I can treat them, those 3 objects, as if they're one single system. Like the 3 cars in a train could be a train. This is what I have, a falling object. So it has weight pulling it down. And for once, yay, we get to deal with air resistance. Air resistance really is negligible for a lot of things, but not for a parachute. There's going to be a lot of force there, so we need to think about it. That's it. There's no normal force because it's not resting on a surface. I'm not going to deal with parachute strings and tension and all that because I've taken the whole thing as a single unit. So let's see, the sum of all forces then will equal the force of the air up and the weight down. Now you have a choice. Which one do you want to be positive and which one do you want to be negative? There are good reasons to do it either way. Weight could be positive if you're following the Atwood convention and saying the direction of motion is going to be positive. Or weight could be negative because it's down. Friction could be positive because it's up. I said friction because that's actually what air resistance is. So I tend to make frictions negative. So I think I'm going to go with an Atwood convention here and say the force of the air is negative and the direction of motion is going to be my positive direction. But it will work fine if you do it the other way also. So let's see, usually I go mass times acceleration at this point, and I'm looking for things I can substitute. I don't even know their mass. I don't know how far I can get without their mass. Let's try this and see. What could I substitute in algebraically for the force of the air? Well, I'm told it's half of their weight. So I can just go ahead and put in half of their weight like that. And then there's weight again. It's possible to do a little math here on this right-hand side of the equation because I have minus 1/2 plus 1. In other words, if I combine those two, I have positive 1/2, right? Well, if I divide both sides by m, kind of at the same time, right? Divide both sides by m, I can solve for acceleration. I think I could substitute something in for that w. That could be mg, couldn't it? Whoa, look at this. Do you remember that? The mass of a falling object does not determine its acceleration. So what I've found here is their acceleration is 1/2 g. So without any number being given to me in the problem other than that fractional relationship of air resistance, I'm now going to pick up my calculator. Please do the same and type in 0.5 times the value of g. Awesome. Look how much you can do with algebra when you don't even know the numbers. You don't even know their masses or anything else about them, but I can still figure out what their acceleration is. So I hope that helps you solve problem 12B, number 1.